So we're going to do another circular motion problem. This time it's going to be a vertical circular motion problem. So here it is. Let's start off with an example. A 10-gram stopper connected to a 60-centimeter string is swung in a vertical circular motion. What is the minimum velocity to maintain this motion? Okay, so let's start off with a picture. So we have our stopper, and it's going in a circular motion. So this is similar to when I showed you in class yesterday about spinning the ball in a vertical motion, and the ball, if the tension was not great enough in the string and gravity was a greater force, then the ball fell short and it actually went down this way. It didn't make the complete circle. So what we're finding right now is what is the minimum velocity that this stopper must be traveling in order for it to make the complete path. So first thing we need to start off with is identifying what forces are acting on this 10-gram stopper. Well, we know tension is down, being pulled downward at this point, and force of gravity is always down. And it's important to identify what direction the acceleration is in as well. So acceleration in this case is down. So when we set up our equation, Newton's second law equation, sum of the forces, specifically in the y direction, because that's all we need to deal with, are equal to MAC. So let's set up this equation up. So both of these, tension and force of gravity, are down. So they're both negative. Negative tension plus a negative force of gravity. Acceleration is also down, so it's going to be negative. So I'm going to put a negative in front of MAC. And we know that our acceleration centripetal is equal to v squared over r. So let's go ahead and substitute that in. So we get negative tension plus negative Fg equals negative mv squared over r. Well, when we're talking about this problem specifically, what is the minimum velocity to maintain this motion? At this point, at the very top, when it's the velocity is the minimum, that means it's just barely going to make a circle, and the tension in the string is actually going to be 0. Okay, so tension's going to be 0. We get a negative mg equals negative mv squared over r. Our negatives and our m's cancel out. Solve for v, you get square root of g times r. When you plug in your numbers, and this is 60 centimeters, I believe the radius was, so that means it's 0.6 meters. You get 2.42 meters per second. Okay, so now let's say that if the velocity is 5 meters per second, it's going faster than the minimum speed, so there's going to be some sort of tension in the string. We're going to want to find what is that tension at the top and bottom of its path. Okay, so let's start off by drawing a picture for both. Let's do the top version first. Okay, here is our picture at the top. The forces acting on the object at the top are the same that we just did. So we have tension down, force of gravity down, and acceleration is also down. So let's write our equation. We get sum of the forces in the y direction are equal to negative tension plus a negative Fg equals a negative MAC. So in this case, we're going to solve for tension. So I'm actually going to add it over onto the other side and then add over my MAC onto the left side. So I'm left with MAC minus Fg equals tension. Rewritten so that your tension is on the left, you can just simply rewrite it. Plug in our givens. We know that acceleration centripetal is equal to v squared over r. We know that force of gravity is equal to mg. Now we can go ahead and plug in our givens. We get 0.01 kilograms because it's a 10-gram mass. The velocity is 5, and the radius is 0.6. And gravity is 9.8. You should get a tension of 0.319 newtons. Okay, so now let's do the same thing for the bottom of the path. Here is our picture. So now the stopper's at the bottom of the path. So the forces are going to change direction. Force of gravity is still down, but tension is now up. Okay? So you can see that the net force on the object is going to decrease. The overall net force is going to decrease. Let's go ahead and write our equation. Acceleration is going upward. So tension is up, so it's positive. Fg is down, so it's negative. And acceleration is up, so we're going to say it's positive as well. Okay? So we get tension is equal to MAC plus Fg, which equals mv squared over r plus mg. When you plug all your values in, and I'm going to let you do that on your own, you should get a tension of 0.515 newtons. Make sure you actually plug in your values and actually check that that's the answer.